going to spend a few moments talking about the concepts of density and its relation to sinking and floating, and trying to do so by appealing to as few equations as possible. And so I promise one of the only times that we're going to have something that seems like an equation is by defining density, because it is a mathematical definition. Density is essentially how heavy something is for its size. And so mathematically that means how much mass there is per how much volume there is. It's quite simply an object's mass divided by its volume. How heavy it is for its size. That is the concept of density. And so the concept of density is crucial when determining whether something is going to sink or float in a fluid. And so with respect to this sinking versus floating idea, imagine that you have some fluid, okay? So imagine like this is a fluid, and imagine that I have a certain volume of fluid. So right now my hand is representing a certain volume of this fluid. And so you can imagine there's more of the fluid that surrounds this. And essentially, if the fluid is static, right, it's just motionless, it's just sitting there, then the fluid has a composition that allows this batch of the fluid, if you will, this volume of the fluid, to just sit there. The rest of the fluid can hold it up. So now we know what the capacity of the rest of the fluid is. The rest of the fluid can hold up the weight of precisely this volume of the fluid, because this volume of the fluid has a particular weight, right? It has a particular mass. And that mass multiplied by the force of gravity is the weight of precisely this volume of the fluid. And if the fluid is static, we know that the fluid is able to hold up the weight of precisely this much volume of the fluid. So here's the thing when it comes to sinking and floating. When objects are put into the fluid, there's going to be some displacement of the original volume of fluid to make room for this new object to enter the fluid. So again, we know that the fluid can hold up the weight of precisely this volume of fluid. So let's first say that there's an object that has exactly the same amount of mass as this volume of fluid being held up by the surrounding fluid. But let's say that the object has a greater volume than the volume of this original amount of fluid. So what's going to happen is the object, as it begins to immerse into the fluid, the original amount of fluid is going to start to get displaced away. But here's the thing. We know the fluid has the capacity to hold up precisely the mass of this volume of fluid. And the object that is going into the fluid has precisely the same mass of this original volume of fluid. So it has the same weight. So that means that the surrounding fluid could hold up the new object because it can hold up the original amount of fluid that has exactly the same weight. But the new object that is displacing the fluid away has a greater volume than the volume of the original weight of fluid that was held up. And so this is to say that if the mass is the same, but the volume is greater for the object going into the fluid, then when the fluid's original volume gets displaced away, the volume of that originally displaced fluid is less than the volume of the object that is being immersed into the fluid, because they both had the same mass and therefore the same weight, and therefore the fluid surrounding can hold it up, both of them. But the new object that's going into the fluid has a greater volume than the volume of the original fluid, and therefore the original weight that was being held up by the fluid. The fluid is now holding up a new weight that's exactly the same, but it's spread out over a greater volume. And so if it's spread out over a greater volume than the original volume of fluid, that means that the original volume of fluid is occupied by the new object, but there's still some volume left over, which means that there's some volume above the fluid, which is to say that it is floating, which is to say that if the masses were the same of the object and the original volume of the fluid that was being displaced, but the volume of the object that is going into the fluid and dispersing some of the fluid away, if it has a greater volume than the volume of the original fluid that was being suspended by the rest of the fluid, that's to say that the object being immersed into the fluid has a lesser density, and i.e. the same mass but a greater volume. And remember, density is mass per volume. And so this is to say that an object that has a lesser density than a fluid is going to float in that fluid. Now let's go the other way. Let's say that we have, again, the original weight of fluid that's being held up by the other fluid, and it occupies a volume. Now let's say that there's an object that we're going to drop into the fluid, and it also has the same amount of mass as the mass of this fluid, but let's say it has less volume. Okay? So the most volume that can be displaced away when something is dropped into the fluid is the total volume of the object being, that's the maximum amount of volume that could be displaced. So if this is the mass and volume of the original fluid, and now you drop something that has the same amount of mass but it has less volume, it is not going to be able to displace away the amount of volume that was originally occupied here, which is to say that all of it goes into the fluid, which is to say that it sinks, which is to say now if the mass is the same as the original amount of fluid, but the volume is now less, that means that the density is now greater than the original unit of fluid. Okay? Remember, this has a certain volume. The object that is being dropped into the fluid has less volume, but it has the same mass. So if the masses are the same, but now the volume is less, now you're going to have a density that's greater. And so this is to say that when you have a greater density object immersed into a fluid of lesser density, the greater density object is going to sink. So, just to review, density is a ratio of mass per volume. When you have an object that has less density than the density of the fluid, then if there was an original amount of fluid which had a mass and occupied a certain volume, then if it has less density, then it is not going to need, when it displaces that original fluid away, it's going to displace precisely that amount, but it's going to have a greater volume than the volume of the original amount that was being able to be supported by the fluid, because this amount has a weight. The fluid can clearly support this weight because the fluid is static. And so when this displaces away and the new object takes its place, if the fluid can also support it and make it float, but it's less dense, if it has the same mass, it means its volume must have been greater than the original volume displaced, which means that some of the volume is above the surface, which means that it is floating. And as I mentioned, for the same amount of mass, if this much fluid was originally suspended in the fluid, and then you have the same amount of mass but occupying less volume, well then when you drop it in, it can't possibly displace the volume necessary, right, to hold up the weight. And so that means that when you have objects of greater density than the fluid, they sink. So an interesting aside here, so it turns out that like when you have matter in different phases, there can be different densities. And what is typically the case is that, so when I talk about the phases of matter, right, I'm talking about solid, liquid, gas. And so when it comes to, say, liquids versus solids, in many cases in the universe, the solid form of matter is going to have greater density than the liquid form of matter. So here's an interesting thing. It turns out that H2O, i.e. water, when it's in its solid form, i.e. ice, has a less density than its liquid form. And so, in other words, when we had the ice age on planet Earth, we had some water freezing and turning to ice. And here's the thing. If the solid form of H2O, ice, has less density than the liquid form, then what happens? Less density floats on top of greater density. So the less density ice would go to the top, and the greater density liquid form of H2O would be down here. So what happened is that you had this protective layer of ice that allowed for warmer temperatures down here. And if it wasn't for ice being less dense than liquid water, then what was happening in the warmer water down here could have been exposed to more cold temperatures, and it could have altered the course of life as we know it.